All right, we have PEMDAS, common points of confusion. In this video, I want to go over that swapping the order of subtraction negates the difference. So here's what I mean. Let's start with 12 minus 5, which is 7. Now, if I take that 12 minus 5 and I swap the order and make it 5 minus 12, it's going to change the positive 7 into a negative 7, just like that. Let's see that again here with 25 minus 9, which is 16. So if I swap that 25 and the 9 and make it 9 minus 25 instead, it's going to change the positive 16 into a negative 16. All right, here in the third example, I'm starting with the negative difference. So 2 minus 5, that's going to be a negative number. What is that? That is negative 3. So if I take that 2 minus 5 and I swap the order and make it 5 minus 2, it's going to negate the negative 3 or make it a negative 3. Here now we have a double negative and that turns it back into a positive, right? So 5 minus 2 is just positive 3 because 2 minus 5 is negative 3, right? Okay, for the next two examples, we're going to make this just a little bit bigger and see what happens. See if you can follow along. We'll start here with 11 minus 5 minus 11 minus 7. Let's evaluate this just like a PEMDAS problem, which says that we have to start with the parentheses, start inside the parentheses. So we have 11 minus 5, which is 6, 11 minus 7, which is 4, and then 6 minus 4 is 2. So I'm going to take that original expression here. Now pay attention to what exactly it is that I swap. I'm going to swap the 11 minus 5 with the 11 minus 7 over the middle subtraction sign. The 11 minus 7 is still the same, and the 11 minus 5 is still in the original order. It's just the two larger portions got switched. So 11 minus 7 is still 4, and 11 minus 5 is still 6. But here now we have 4 minus 6, which is negative 2. So compare that to the original answer, which was positive 2. We swapped the two large chunks around the middle subtraction sign, and that turned it into a negative 2. Let's do that again, but with some multiplication here. So we've got 2 times 5, which is 10, minus 3 times 3, which is 9, and then 10 minus 9 is 1. So let's take that original expression and swap it around the middle subtraction sign. Now we have 3 times 3, which is 9, minus 2 times 5, which is 10. 9 minus 10, that is now negative 1. So swapping the order of subtraction negates the difference, right? Here we go. Let's keep going. I'm going to try to show you some other perspectives here that you could implement into larger PEMDAS problems. So let's go back to just something like 7 minus 13, a little bit smaller. But here's really the main point of this video is I'm targeting students who struggle with negative differences. So let's say that you really can't wrap your mind around what 7 minus 13 is. That's okay. We can switch this so that you can evaluate 13 minus 7 instead. You just have to remember that it spits out a negative. So take that 7 minus 13, swap it, but negate it. Put a little negative outside. Now, evaluate 13 minus 7, which is a positive difference, right? 13 minus 7 is 6, meaning the answer is negative 6. So 7 minus 13 is negative 6, and you can kind of trick that, get around that by evaluating 13 minus 7, which is positive 6, and then just making it negative. But what if your expression starts with a negative out front? We'll get there in a minute. Start with 2 minus 13. That's a negative difference. Say you don't want to deal with that. So you decide to swap it into 13 minus 2. But that pushes out another negative, meaning there are now two negatives out front, and a double negative makes a positive. Now you can evaluate 13 minus 2 instead of 2 minus 13, which is 11. Bring down the positive. Positive 11 is redundant with that plus sign, so you can just write it as a normal 11. Good. What if it had a negative coefficient out front, meaning there's another number out front? What do we do then? Well, here, I'll show you. Start with that 1 minus 6. It's a negative difference. Maybe you don't want to deal with it, so you decide to swap it into a 6 minus 1. When you do that, it turns the negative 3 to a positive 3. Now evaluate. 6 minus 1 is 5, and 5 times positive 3 is 15. 14. So that would be the answer there. All right, for these final two examples, I am going to implement what I've been teaching you. Now, let me say this beforehand. You do not have to do these last two examples by swapping subtraction. There are many different ways you could do these. This is just if you personally do not like negative differences. But by all means, do what makes most sense to you. Well, as long as it's mathematically correct. So here, in parentheses, we have 5 minus 9. Now that's a negative difference. Maybe you don't like that. So you're going to switch it to a 9 minus 5. You can do that, but it's going to change the positive 3 into a negative 3. Now evaluate 9 minus 5. That is going to be 4. And then multiply 3 times 4 is 12, and 16 minus 12 is 4, and that'll be your answer right there. So again, that problem doesn't have to be done that way, but it can be done that way. And here we got one more. In parentheses, we have 1 minus 4. That is a negative difference. So if you want, you can swap that around, make it a 4 minus 1, but it's going to change the negative 2 into a positive 2. Now evaluate. 4 minus 1 is 3. 3 times 2, that is 6, and 8 plus 6 is 14. So awesome. Again, I know I'm repeating myself here, but this is all designed to do a trick that you don't necessarily have to do if you don't want to. But if it makes sense to you, awesome. Hopefully this helps you with subtracting numbers when the difference is negative. Thank you for sticking around. We'll see you in the next one.